Here's another problem from homework number 11, and as you can see, I've already put the probability of an event at the top of the page because you just know that it's always going to be the same. So a fan of country music plans to make a custom CD. Hopefully you guys know what a CD is, with 12 of her 28 favorite songs. How many different combinations of 12 songs are possible? All right, so in this case, we're not actually finding a probability yet. We'll get to that in the second part of the question. At this point, what we really need to do is find how many different combinations there are for 12 songs out of a total of 28 to choose from. So that's really the bottom thing here, these outcomes, the total outcomes, the total different ways. So going back to our old method, we can actually just make 12 lines, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And just like we've done before, we can basically choose, we have 28 to choose from for the first song, and 27 for the second, 26 for the third, all the way down 25, 24, 23, 22, 21, 20, 19, 18, 17. Now this isn't going to go all the way down to 1, so we can't just pop in our calculator 28 factorial. We could do that if she was going to arrange all 28 of her favorite songs. The other problem with this here is that these are going to include order. So for example, I could choose song A first, and then song B, and then song C. However, when I choose song C and then say song A and then song B, it's going to count it as two different, it's going to be counted in that as two different outcomes. But up here, order doesn't matter. So I'm going to have to divide through by all those multiples of the same thing occurring, just in different order. So with combinations, order does not matter. Order does not matter. We'll get into permutations in another video where order does matter. Okay, so we actually have a formula here because this is not a very practical way to plug things into your calculator. 28 times 27 times 26. And we really can't do factorial because if we did 28 factorial, that would include, we had to change a color here, that would actually include all this, 28 all the way down to 17, but then it would keep multiplying times 16, times 15, times 14, and so on, all the way down to 1. And that's what the 28 factorial would give us. However, if you think about it, what if we were to divide through by this 16 factorial, right? If we divided all of this by 16 factorial, think about that, right? What would happen is we'd have 16 times 15 all the way down to 1, and all this would cancel out with all of this. And look what's left, just what you want. So that's already an easier way to type it into our calculator, is 28 factorial divided by 16 factorial. But we also have to take into account this doubling up. We have to divide through by these double ups, and that is going to, nice and simply, just be the 12 factorial. All right, there we go. And this is what we call a combination. And another way of writing it would be 28 choose, think of it like the letter combination, or choose 28, choose 12. That's what we're doing. We are choosing 12 different songs out of a possible 28 where order does not matter. And that's an actual formula that we have. It goes like this. Combinations are known as n choose r is equal to the n factorial, which is your total number that you're starting with right here. That's your numerator, divided by the r, which is the number that you're actually choosing, the r factorial, also multiplied by, this 16 is actually coming from 28 minus the 12, because the first 12 numbers are right here, and you're subtracting off the remaining 16, which comes from actually the n minus the r, and then that factorial. Okay, So this is a formula worth recognizing, but it's not something you have to memorize. And in fact, your calculator will do it for you. And you can try that right now. For most of you, there's a probability button. So you can click on doing this example here that we have. We can go to our calculators. We can type in the number 28. Then click on the probability button. You'll see you've got 3 choices. We already know the factorial button. We're going to go down to the N, choose R, hit enter, and then you're going to punch in the number 12, and then you're going to hit enter. And that's doing all that calculating for you. It's doing all those factorials. It's basically, this number is going to equal 304. 21755 is what I get. And that is 28 times 27 times 26 times 25 times 24 and so on all the way down. It's this many 30,421,755 different ways that she could create her songs. So when it asks, is it practical to make a different CD for each possible combination, I'm thinking no. That would take you a lifetime, right? All right, give this one a try. And if we'd actually been asked a probability question, which we were not in this case, but hypothetically, if I were to ask you what's the probability she chose, the songs that she chose happen to be the 12 longest songs, the probability that they happen to be the 12 longest songs, what would be the probability of that happening? It would be the 1 out of this whole big number. So you just got to read the questions carefully, and is it asking for a probability, or is it asking for a number of ways? This one was a number of ways, so that's going to be our answer. All right, give one a try.